Okay, we are looking at section 2.3, polynomial and synthetic division. To help in factoring and finding zeros of polynomials, you need two procedures for dividing polynomials: long division and synthetic division. All right, so before we get into polynomial division, can we just review what you must have learned like back in 3rd grade or 4th grade? How would you divide, for example, 57 by 4?
Okay, so you write 57, or you do that.
Let's do this. 4 goes into 57. So we would say 4 goes into 5 once. Then what do we do? Multiply, right? Multiply the 1 times the 4. And I write it here. And then I subtract. And I get what? I get 1. Then the next step is to bring down the 7. Now I say 4 goes into 17 4 times. Then what? Multiply that 4 by this 4, and I get 16. Subtract again, and I get 1. Do you remember what this part of the problem is called?
That's the denominator.
No,
Dividend. And what's this part called?
Differential.
divider.
Almost. Divisor. This is the quotient. And what about this?
The number.
The decimal.
The remainder. Okay, so how would we write our answer for this problem? 57 divided by 4. It's 14.
R1.
Okay, we're not going to be using R1. That's kind of a 3rd grade thing.
4.
Thank you. So we're going to say 14 plus 1/4. In other words, we write the quotient plus the remainder over the divisor. Divisor. Yes, polynomials. Yes. All right. So at this point, now that we've reviewed the process, that process is going to be the same when we want to divide polynomials. So let's try this example. Is this one on your gift or no? No. All right, so put this one in your notes, please. Put this one in your notes. We're going to put our divisor, which is x squared plus x minus 1, out in front. And we're going to have 6x to the 4th minus x cubed minus x squared plus 9x minus 3. That's our dividend. That goes there. Well, here's what we're going to do. Here's the process. You're going to focus just on this leading coefficient and this leading coefficient, or this leading term, I should say, of the divisor, and the leading term of the dividend. All right, just focus on those for right now. And so we're going to say x squared times what gives me 6x to the 4th? 6x squared. Now remember the process. Once we had started with this, we said, oh, 4 goes into 5 one time. What did we do next? We multiplied. So we need to do the same thing, but we're not just going to multiply 6x squared times the x squared. We got to multiply by this whole thing. So 6x squared times x squared is 6x to the 4th. 6x squared times x, and 6x squared times a negative 1. Minus 6x squared. Notice we're keeping everything lined up. So I've got x to the 4th lined up, x to the 3rd lined up, and so on. The only way you can keep everything lined up is if you fill in 0 for any missing terms. Like if I didn't have an x squared term, I wouldn't just write 6x to the 4th minus x cubed plus 9x. I would have to fill in a plus 0x squared. Does that make sense? You got to fill in 0 for placeholders. Same thing in your divisor. If you're missing a term there, you got to fill in a 0x or whatever. Okay, so at this point, what was our next step in this process? After we multiplied, when we wrote it here, what did we do? Subtract. So we're going to need to subtract. I strongly recommend that you put a big parentheses around this whole thing, put a minus in front, but since we're subtracting, let's change this to addition, and then we're going to change the signs in this second polynomial. Now it's just adding. All right, so when we do 6x to the fourth plus a negative 6x to the fourth, that's 0. I'm not even going to write that. Negative x to the third plus negative 7x to the third, negative x squared plus positive 6x squared. 5x squared.
Yes.
What's the next step?
Plus 9x.
So,
Minus 3.
all right, but I'm only going to bring down the 9x. I don't want to bring down too much because I want to have the same number of terms here as I have in my
Ooh, good call.
divisor. So at this point, we are going to focus only on the x squared and the negative 7x cubed, and the process repeats. So what am I going to need? All right, so I say x squared times what gives me negative 7x cubed? That's a negative 7x, and I'm going to multiply the negative 7x by all three of these. So I'm going to get what? Negative 7x cubed minus 7x squared plus 7x. Are we okay with this? We now need to subtract, so put a big parentheses around this whole thing, put a minus out in front, and I strongly suggest you change the minus to a plus, and then change all of these signs here. Now you're adding. So we add, that's going to go to 0. Then we're going to have what?
13.
Is it 12 or 13? 12x squared
Plus 2x.
plus 2x. Bring down the 3 and do this one more time. We have to keep going until the degree here is less than the degree of our divisor. I don't know. I don't think so.
No, just one more.
All right, so what do we have to say here? So x squared times what? Remember, we're only focusing on, not that, only focusing on the x squared and the 12x squared. So plus 12. So I'm going to multiply 12 by each of those. 12x squared, 12x, minus 12, right? And I'm going to put a big parentheses around this, and I'm going to subtract. And is that right? So we're going to change this to a plus, change all of these signs here. And what do we end up with?
10x plus
Negative 10x
9. Sorry.
plus 9? Okay, so what is this negative 10x plus 9?
The remainder.
That's the remainder. So how are we going to write our answer for this problem? Remember, we want to write our answer as quotient plus remainder over divisor.
Squared, 6x squared minus 7x plus 12.
Whoops, 6x squared.
Minus 7x, 9x plus 9.
So I'm going to write plus a negative 10x plus 9 over.
X squared plus x minus.
All right, so this is my answer for this problem. Are we okay with this? All right, so would you please try number 1 on the gift? You're doing this one using long division of polynomials. Okay, so for this problem on the gift, if you did this problem, you got 2x squared minus 3x plus 1 as your quotient, and really the remainder is 0, so we could write plus 0 over x plus 2, but you don't have to put that in, right? But it is important to note that if you do get a remainder of 0, that means that x plus 2 must be a what of this polynomial?
0.
Factor, right? X plus 2 must be a factor, all right, of that. Now, let's talk about the other type of division, all right? There is also a technique called long division. I'm sorry, this is long division. Let's talk about a technique called synthetic division, all right? All right, so if you were dividing by x plus 2, if x plus 2 is a factor, then what would be a 0? All right, so to start off this synthetic division process, we're going to take this number, negative 2, and we're going to put it in a little box like this. and we're going to take the coefficients of the dividend. So this is at 1 here, -5, 2, and we're going to put them next to that box. If there were any missing terms, you'd have to fill in zeros for those. Fill in zeros for missing terms. All right? Here's the process for synthetic division. So this is what we're all about right now. Synthetic division. All right? The process goes like this. You put that number in the box that we talked about. You put your coefficients next to it. You don't need any x's, right? You don't have to write any variables down. Okay? You're going to fill in any zeros for missing terms. You're going to leave a little bit of room, and you're going to put a line like this. All right? Focus and follow this procedure. Your first step is going to be to bring down this leading coefficient, that 2, and put it right below the line. Then the rest of the process is just a series of multiply, add, multiply, add, multiply, add. So we're going to multiply the number below the below the line by the number in the box. So -2 times 2 gives me -4, and I put that right here under the next number, but I put it above the line. At this point, I just add 1 plus -4, and I get -3, and the process starts again. So I'm going to multiply the number below the line by the number in the box, and I'm going to get 6. So I put that here, and then I add, and I get 1. I put that below, continue, and I get what? -2, and I add, and I get 0. All right? This last number, I'm going to kind of put a wall around that, because this last number is my remainder. And these numbers here are the coefficients of your quotient. This is a different way to divide polynomials. It's a much easier, much faster way. Let's finish this up, though. What do I mean by coefficients of quotients? So right next to your remainder, right next to your wall, the number that's just to the left of your wall is really your x to the 0 term, meaning it's your constant term. The number to the left of that is the coefficient on your x to the first term. The number to the left of that is the coefficient on your x to the squared term. So my quotient is 2x squared minus 3x plus 1, and I have 0 as my remainder. Does this match your answer that we got here? Yes, it's the same answer, right? Okay, questions? All right, we're going to do another one for practice.
How do you know if x plus 2 is a factor?
The question was, do we get to choose which one we want to do, or do we have to know how to do both? Well, the answer is you do need to know how to do both. I will be asking you on a quiz or a test, divide this by long division, divide this by synthetic division. But there is a limitation to the synthetic division. You can only do synthetic division if you are dividing by x plus a number or x minus a number. So could we have done synthetic division on this one? No, we would have to do long division on this one. Does that make sense?
So x can only be to the first power?
Yeah, it's always got to be, and it's got to be 1x. You can't use synthetic division if it's divide by 2x minus 5. Can't do it.
Like if it's 2x minus 2 is like the factor, you could do x equals 1. It's going to be 2x equals 2 divided by 2x equals 1.
I understand what you're saying, but it has to be x plus a number or x minus a number, okay, to use this. Alex.
So, like, what was the next part in that? Like 5?
Are you doing, which one are you doing? This
Number
one?
3.
Okay, first of all, you missed a 0. You got to fill in a 0 for the missing term there in number 3. Right. No, it's got to be just x plus a number or x minus a number. Okay. So we did that. Okay, so let's talk about this division algorithm and then we'll get back to some more of the examples on the gift. The division algorithm says this: d of x and f of x are polynomials with the degree of d of x less than or equal to the degree of f of x. There exist two polynomials, q of x and r of x, so that f of x is equal to d of x times q of x plus r of x. All right, so d of x stands for like divisor, right? Q of x stands for quotient. R of x stands for remainder, and so on. So let me copy this for a moment. Where's my... Why is it doing that? That's kind of disappointing. Why is it doing that? My frustration is being recorded. Why is it doing that? All right, anywho. All right, I'll just take it. Okay, so I wanted to go back to this first problem to demonstrate this. Okay, so if we have this, forgive the nasty line through there, but if we have this, the original polynomial is going to be our f of x. So that's this 6x to the 4th minus x cubed. You with me? So can you take this example here and write it in this pattern here? Would you do that now, please? Well, d of x times q of x plus r of x would get you back to f of x. You could think of it that way. It's another way of writing this. I'm asking you to fill in the f of x, the d of x, the q of x, and the r of x for this example that we did first thing. So, Paul, what's our f of x in this case? It's going to be our dividend. No, the dividend is this part here. Right?
Yeah.
So I'm going to write 6x to the 4th. What was the rest of it? Minus x cubed. Minus 9. And that's going to be equal to, what's our d of x?
The divisor?
Uh-huh.
So the divisor is x squared plus x times 1.
Okay. And then times q of x.
Quotient, so 6x squared plus 7x plus 12.
All right. And then plus,
Negative 10x plus 10
no, just the remainder, just like that. So this is our f of x here, equals, and then this is our d of x, no, yes, d of x times q of x, and then plus the r of it. Does that make sense?
Is that like standard form?
But it's another way of writing our, so instead of saying,
You can do that if you've already solved using long division or synthetic, right?
you can write it that way if you've already done the division problem.
So
Okay.
what you would ask us to solve,
You would say
On some of the homework problems, you're asked to write your answer in this form. Does that make sense? No, I think it's just a way of writing it. I don't know if it has a name. Okay, so let's get back to, where were we? Okay, right here. So where r of x equals 0 or has a degree less than the degree of your divisor, right? We talked about that. Remember, you keep dividing until what you think is the remainder has a degree less than the degree of the divisor. Allison?
Are we going to have to memorize that?
No, you will not. Okay, this is just some things we've already talked about. Before long division, write the dividend and the divisor in descending powers of the variable, right? You got to have them all in order, and you got to fill in placeholders with 0 coefficients. We talked about that. Okay, and okay, did we do this one? Okay, so let's do this one. Let's try this one with synthetic division, since we are dividing by x plus a number or x minus a number. What number would we put in the box? -1, because we set this equal to 0, to find the number that would go in the box, right? And we'd end up with -1. What numbers am I going to put next to the box?
1 and -1.
1, 0, 0, 0.
Oh.
All right, so you have to fill in the missing terms. Remember, this is our x to the 4th, x to the 3rd, x to the 2nd, x to the 1st. I didn't have any of those, so I had to fill in zeros. And then my constant, this is my x to the 0 term. So then the process is you bring down your leading coefficient, multiply, add, multiply, add, multiply, add. Brendan, talk me through this. What are we doing?
All right, so you take -1 times 1,
Mm-hmm.
and you -1, you put that right there, and then subtract.
Add.
-1, well, I mean, okay, add -1 to 0 is -1.
Okay.
Then you're going to multiply that by -1.
Okay.
1.
Okay.
Add 0 plus 1.
Okay.
Multiply that by 0 plus 1.
Okay.
That's 0.
Okay.
Multiply 1 to 1.
Okay.
Subtract.
All right. Now, are we always going to get 0? No. It just happens that, again, the remainder turns out to be 0, which means that x plus 1 must be a what of x to the 4th minus 1? A factor. All right, so this here, remember, is our remainder. And then what is the answer to this division problem? You divide, and you're going to end up getting what? Angelo?
Okay, so it would be x to the 4th.
Well, remember, this, you start right next to the box. You're going to start with x to the 0, right? And then x to the 1st, 2nd, 3rd, right?
Oh, then I messed it up. Okay.
So what's it going to be?
X to the 3rd minus x to the 2nd plus x to the 1st minus 1.
-1. Are we okay with this? Does that make sense for our answer? And again, if I had something other than 0, I would have to say plus, whatever, over x plus 1, right? But in this case, it was 0, so I can just leave that part off. Are we okay with this? All right, what else do I have for you? Okay, synthetic division, we've already talked about this. Is this example on your gift or no?
Almost, not quite.
No?
It's x minus 4.
All right, it's okay. Oh, you got this one? All right, yeah, go ahead and do that one.
Oh, wait, so what we just
Does this one turn?
Is there a remainder?
Is there a remainder?
It's
Oh, good. Good. I'm glad there's finally a remainder, so you don't think, oh, every time I do synthetic, I get a remainder of 0. What number am I putting in the box? 4. What numbers am I putting next to the box?
5 minus 6, 0, 8.
0 and 8. You must have that 0, or you will get the wrong answer. Justin, talk me through this, please. Okay? 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 56? Okay? What's 4 times 56? 224. And we add and we get 232. So we wall that last number off, and we're going to write our answer as what, Lindsay?
It would be
Remember, just to the left of the wall is your x to the 0, then the one next to that, x to the 1st, x to the 2nd. So what's going to be?
5x is like
Plus 56?
And there's a
Plus?
232.
Lindsay's answering. What is it?
232
Over
x
x minus 4. Are we okay with this? All right. So now we can say x minus 4 is not a factor, right? Because we did not get 0 for a remainder. Everybody okay with this? All right. Oh, okay. Let's talk about this problem. Is this on your gift?
No, yeah, no.
Yeah. No? Okay, we'll put this in your notes then. So, example, let's say f of x is equal to 4x cubed plus 10x squared minus 3x plus 9. And I'm asking you to find f of -1 in 2 different ways. All right? So, I'll say here is method number 1, and over here we'll do method number 2. Method number 1 I would refer to as direct substitution. Right, that's what you're used to doing. If I want to find f of -1, that means I got to plug in -1 wherever I see an x. You know what I'm talking about? All right, calculators, or do what you need to do to get me an answer for this problem. I think I need a little bit more room for method number 1. What are you getting? 18? All right, so I am getting that f of -1 equals 18. That's method 1. It's called direct substitution. It's what you're used to with evaluating functions. Method number 2, I would call this one synthetic substitution, or I think your book still calls it synthetic division. But you would do the same type of thing that we've been doing with synthetic division. We're going to put the number that we're trying to evaluate the function at in the box. So I'm going to put -1 in the box. And then we're going to do the synthetic division process. So what number should I put next to the box? 4, 10, -3, 9. Can you talk me through this process here, Brianna?
Bring the 4 down.
Okay.
And multiply that by -1.
All right. Adam gets 6.
You multiply that
Okay. Okay.
you multiply that by
Okay. All right. What are we noticing? The remainder, there is a remainder, but not only that there is a remainder, but the remainder actually is what? Is it positive 18? But isn't it the same as what we got over here?
So we wouldn't put it, so like it wouldn't be like 18 over -1.
Right, so in other words, we were not just asked to divide. We were asked to evaluate the function f of, evaluate the function when x equals -1. In other words, find f of -1. But the point is, if you do the synthetic division process, the remainder that you get is actually the value of the function at that point. So f of -1 is equal to 18, no matter which method you're using. Does that make sense?
Yes.
All right, and sometimes this is probably faster than plugging in something, you know what I mean? It could be faster. Anyway, it's just another method. Sydney?
Can we use that one all the time because there's no limitations on it?
All the time, yeah, all the time. Okay, no limitations. Okay, so you can test to see if a polynomial has x minus k as a factor by evaluating f of k, either with direct substitution or synthetic substitution. And if f of k is equal to 0, then x minus k is a factor. All right, the factor theorem says a polynomial f of x has a factor x minus k if and only if f of k equals 0. All right. Okay, is this example on your gift? Almost. This one says show that x plus 3 is a factor of f of x equaling x cubed minus 19x minus 30, and then find the remaining factors. If it's not on your gift, please add this one to your notes. We are trying to show that x plus 3 is a factor. So how are we going to show it's a factor? We're going to use synthetic division, and we're going to hope that the remainder is what? 0. So go ahead and do that. What are we putting in the box? -3. What numbers are we putting next to it?
1, 0.
We need that 0. All right, go ahead and do this and show that you are getting 0 as your remainder. Okay, so at this point we do the synthetic division. We do see that we get a 0 for a remainder. So that means that yes, x plus 3 is a factor. So here's what I want you to notice, and this is important. This was our original function,
Yeah.
but that means now that we've discovered that we ended up with a 0 for a remainder, that means I can write this in factored form as, what's one of the factors?
X.
We just said that we got a 0, which means that what's a factor?
X minus 3.
I don't think it's x,
X plus 3.
x plus 3, but x plus 3 times what?
X squared minus 3x minus 10.
Thank you. So this right here is giving me the coefficients of my other factor. Does that make sense? And now the directions say find the remaining factors, which makes me think that maybe this is factorable. Is it?
No.
No, not.
Actually, no, 5 times.
Oh, yeah, 5 and 2.
So x minus 5, x plus, does that work?
Yeah,
All right, so that means that our function could be written in factored form like this. Are we agreeing? And then this problem didn't ask you to find all of the zeros, but now we could, right? All the zeros. All right, so the zeros would be -3, 5, and -2. Are we okay with this?
Yes.
All right. Okay, well, I'm going to skip that one, but we already solved it, right? Those are going to be the zeros. Okay. Uses of, I'm just going to go through this quickly because I want to get to that last example on your gift. Uses of the remainder in synthetic division. The remainder are obtained in the synthetic division of f of x by sum x minus k provides the following information. The remainder r gives the value of f at x equals k. We just did that like when we did f of -1 was equal to 18, right? We did an example like that. If the remainder r is equal to 0, then we know that x minus k is a factor. And if r is equal to 0, then k comma 0 is going to be an x-intercept of the graph of the function. All right. Okay, awesome. Now we get to this last example. This is on your worksheet. It says f of x equals x to the 4th minus 4x cubed minus 15x squared plus 58x minus 40. You are asked to verify that x minus 5 and x plus 4 are factors of this function. All right, how would we verify, for example, that x minus 5?
You first put 5 in the box.
All right, so you're going to do synthetic division and with 5 in the box. Would you do that, please? Put 5 in the box, do synthetic division, and then just hold for a moment.
Sure.
Is it working? Yes?
Of course it is.
All right, so at this point, you're asked to now verify that x plus 4 is a factor. But here's where I want to, don't do anything yet, just listen. You could just go ahead and plug in -4 in the box and use these same numbers here again, but that's not going to help you answer the remaining parts. So what I want you to notice is, and I'm not really doing part E, I'm just rewriting my function, x to the 4th minus 4x cubed minus 15x squared plus 58x minus 40. But what we now know is that we can rewrite this as x minus 5 times what?
X squared plus x squared minus 10x plus 8.
So x cubed plus x squared minus 10x plus 8. Everybody agree?
Yes.
But here's the point. X plus 4 is still supposed to be a factor of this, but that means that x plus 4 must be a factor of this. So I want you to do synthetic division again, but use these numbers here. You with me? That way we can break it down even further and get the next factor where we would not have been able to do that if we just went back to the original. So you're going to put, what are we putting, -4?
4.
-4 in the box, and these coefficients, 1, 1, -10, and 8, and do synthetic division with that. Does that work?
So it's 1 negative 3, 2.
What'd I do?
Yeah, but
Negative 10.
Oh, positive 12.
positive 12.
I knew I had a mistake here somewhere. Positive 12, so that's a 2, that's a negative 8, and I get a 0. All right, so that means that this remaining factor, here's my x minus 5, and my remaining factor here is what? Plus 2, right? So, well, we just verified, we did this, right? Did we find the remaining factors? Can this be factored further?
Of course.
X minus 2, x minus 1. Does that look right? So I have, keeping all this color-coded here, so that means my function f of x could be written like this. Are we okay with this? So how are we doing on this whole problem? We found the remaining remaining factors. We wrote the complete factorization. Can we list all the zeros? 5, negative 4, 2, and 1. Does that look okay? And then graph the function by using the leading coefficient test. Well, what's the degree of this polynomial? Oh my gosh. It's degree 4. Leading coefficient is positive or negative? Positive. So it starts high, ends low, starts low, ends high. Starts high, ends high. So we know that the general graph, general shape is going to be, something like this, perhaps, right? But I don't know where it should go, except I do know that I'm having zeros at.
Just 1, 2, negative 5, 4.
Well, I want you to be able to do this by hand. So negative 4, 1, 2, 3, 4, 5. Like this. So I want to fit this general shape through those zeros. You with me? Can you go ahead and sketch that for me, please? How do you know what?
When it makes a curve. She's asking, how do you know, when it bounces?
Oh, well, I mean, it's got to cross through at a certain point. You know where it starts and where it ends and where it's supposed to cross or bounce. Is the graph crossing or bouncing at these?
Always crossing, because they're always odd.
All right, odd multiplicity, so they're crossing.
I think I missed the graphing, how to graph.
That's in this section too.
How do you know?
That's a big part of
it's
2-2. That's a big part of 2-2. Okay. I have that video recorded. I
Okay,
think.
so I'll
Okay. If not, let me know. You get that?
process.
Because all of these zeros are showing up one time each, right? None of these were x minus 5 to the second. So, does that make sense?
So it always crosses.
So it's just going to cross at each one of those because it's multiplicity 1. So I think the idea with this graph is it's going to start high, it's going to cross through here, cross through here, cross through here, cross through here. So it's going to look something like this.
How do you know that it doesn't start like it flipped upside down?
How do you know that it doesn't start?
Oh, because it opens up because it's pot the whole.
Because the degree is even, right? It was a degree 4. It's an even degree. That means it starts and ends in the same place. And because the leading coefficient is positive, it's going to end high. So it means it's got to start high and end high. All right, Louis.
How are they all odd when the degrees are like 4, 3, 2, and 1?
The multiplicity just means how many times does that 0 occur. So 5 only occurs once, so it's got a multiplicity of 1. Negative 4 only occurs once, so it's got a multiplicity of 1. Does that make sense? Okay, and I think that's it for our notes.
Bye, Billy.
Bye, Hertz.
Unicorns! Banana! Hey, we're coming.